In the previous section, we looked at the limit definition of the derivative. So that's the limit as h goes to 0 of f of x plus h minus f of x, all divided by h. So we were looking at that to find derivatives of a variety of functions. And as you could, you tell by now, that's a very slow process for most functions. Even the really simple functions, it still takes a lot of steps and it's a lot of writing things out. But thankfully, there are a lot of different rules that we can use to make this process so simple that you wouldn't even think twice about using these techniques versus the limit definition. So if we look at the first example, actually, let's look at the power rule itself. So it says d dx of x to the n equals n times x to the n minus 1. And that looks complicated in a way, but it is the simplest of all of the rules, and it's one of the most useful ones. So for this first example, we have f of x equals 3x squared. Find f prime. Okay, so f prime of x, all I'm going to do is apply this right side of this equation. So I bring the n value down. So it's 2 times 3 times x, and then I go 2 minus 1. So my n in this case is whatever is in the power. So this is a 2. And then we just simplify. So this is 6x. Okay, so unless you can just burn through that limit definition of the derivative, you can see that this is super simple. It's a one-step problem. Okay, next, 1 over x squared. Let's take the derivative of that. Well, that one can't be done directly using the power rule because we don't have a power in the numerator like that. So we just rewrite it as x to the negative 2. So that's just your algebraic rule that says you can do that. Now we can use the power rule. So we bring the negative 2 down front, subtract 1 from negative 2 to get negative 3. Okay, and if you want to clean that up, you could say negative 2 over x to the third. Okay, let's do a couple of these. Cubic root of x, find f prime. So again, we have to rewrite this one so that we can see a power. So this is x to the 1/3. And I'll write down the little minus ones and all that in this case. So f prime of x is going to be 1/3 times x to the 1/3 minus 1. Now, you'll get really used to subtracting these fractions. You'll be able to do this in one step, but that's 1/3 x to the 1/3 minus 3 over 3, or 1/3 times x to the negative 2/3. And if you want to clean that up like the last one, you could say 1 over 3 times the cubic root of x squared. Okay, next, f prime of x when you have 3x. Well, the exponent on the x is 1, so we have 1 times 3x to the 1 minus 1, which gives us 3 times x to the 0. Anything raised to the 0 power is 1, so this is just 3. So if you have a linear function, which 3x is, and you take the derivative, you're always left with the constant, and that's it. Okay, in this example, I'm going to write this out a little differently, but you don't have to do this. Normally, I would just take the derivative like I did in the last couple of problems. But if you're given something like this, where you have a polynomial, multiple terms, what you're doing is taking the derivative of every piece of it. So I'm going to use this Leibniz notation. So you're going d dx of 2x to the fifth plus d dx of x to the negative 1 minus d dx of x cubed. Okay, so just know that these are operators, so they're telling you to operate on it. So the derivative, or dy dx, I'll keep it in that notation right now. is equal to 10x to the fourth negative x to the negative 2 and negative 3x squared. So that is the derivative of that function, and we could just leave it like that. You could put that exponent in the denominator, but it's not necessary. Okay, so like I said, I wouldn't normally write all those ddx's out. That's just to show you that we have to do the same thing to every term. So we're just taking the derivative of each individual item. Okay, so y equals 3. Okay, so what is y prime? Well, what's the slope of the line y equals 3? What kind of line is y equals 3? And that is a horizontal line, so that means that the slope is 0. So if you have a constant like that, the slope is 0. So I'm going to write this one out as a rule. So the derivative of a constant is always 0. Okay, so this one. So this one again is in a little bit different form because we have this fraction. But since that's just a fraction, 1/4 is a constant. So y can be rewritten like this: 1/4 times x squared plus 1. Okay, so we can take the derivative of those parts inside. So you would get y prime equals 1/4 times 2x. And then that's going to be, the derivative of this 1 is 0. So that's all we'd have. And simplify it. So this would be 1/2 x. Okay, and this is what we applied there right here is the constant multiple rule. If u is a differentiable function of x and c is a constant, then the derivative with respect to x of cu would just be c times the derivative with respect to x of u. So basically you can bring the constant out to the front. That's what all that translates to.